At Shanghai Pudong International Airport, anticipation filled the air as China's C919 prepared for its first commercial flight. The gleaming white jet, bearing China Eastern Airlines' green tail, stood as a symbol of national ambition. Crowds of engineers, officials and journalists watched, knowing this was more than just another plane. It was a declaration of technological independence. For decades, Boeing and Airbus dominated China's skies, a constant reminder of reliance on Western technology. Today, that story changed. The C919's takeoff was a moment of vindication for the engineers who had dedicated their lives to this project. This jet was not just assembled in China, it was designed and increasingly built by China. Its ascent mirrored the nation's own rise, marked by persistence and vision. The flight from Shanghai to Beijing was routine, but the aircraft made it historic. Passengers marveled at the modern cabin, aware they were witnessing a paradigm shift. This was more than a victory for COMAC. It was a signal that China was ready to compete on the world stage. The Dragon had not just woken, it had taken flight. For over 40 years, Chinese aviation was shaped by Boeing and Airbus. As China's economy soared, so did its need for thousands of planes to connect its vast cities. Boeing and Airbus jets became the backbone of China's fleets, deepening a multi-billion-dollar dependency on the West. This reliance modernized China's aviation sector but left the country vulnerable, always a customer, never a partner. China had little control over pricing, technology, or supply chains, a strategic weakness for a rising superpower. The dream of building a homegrown passenger jet had simmered for decades, but early attempts faltered. Leaders learned that true independence required a long-term strategy and a robust industrial ecosystem. The dominance of Boeing and Airbus became both a shadow and a motivation. As China's ambitions grew, so did the urgency to break free from this duopoly. Relying on foreign aircraft was no longer sustainable for a nation with global aspirations. The stage was set. China would marshal its resources and brightest minds to build its own jet. The goal was clear: create a Chinese challenger to stand with the giants. The journey was about to begin. In 2008, China launched the C919 project and established COMAC to lead the way. The mission designed a narrow-body jet to rival the Boeing 737 and Airbus A320. The name C919 carried national symbolism and ambition. COMAC knew the challenge was immense. Building a modern airliner meant integrating millions of parts from hundreds of suppliers. To bridge the technology gap, China sourced critical components like engines and avionics from Western companies, while focusing on domestic design and assembly. This approach allowed rapid progress and knowledge transfer with the long-term goal of building up local capabilities. The C919 became a catalyst for China's aerospace ecosystem, spurring new research, specialized university programs, and a network of domestic suppliers. Thousands of engineers coordinated this complex project, ensuring every part met strict standards. The C919 was more than an airplane, it was the seed of an industry. China was investing in a future where it would not just assemble planes, but create them from scratch. The engine is the heart of any aircraft, and China's biggest challenge. Only a handful of Western companies could supply the high-bypass turbofan engines needed for the C919. COMAC chose the LEAP 1C engine from CFM International, ensuring the C919 could compete with the latest Boeing and Airbus models. But this reliance on foreign engines exposed a critical vulnerability. As long as the C919 depended on imported engines, China's aviation ambitions were at risk from external pressures. Determined to achieve self-sufficiency, China launched the CJ1000A engine project, consolidating expertise under AECC. The technical hurdles were immense, mastering advanced materials, precision engineering, and complex software. Many doubted China could catch up, but the nation pressed on, pouring billions into R&D. Only a homegrown engine could secure China's place as a true aerospace power. As the C919 gained momentum, it faced a new threat: geopolitical turbulence from Washington. The US saw the C919 as a strategic challenge and responded with export controls and sanctions, targeting Chinese aerospace firms. The goal slowed China's progress by cutting off access to essential Western technology. The C919's global supply chain, once a strength, became a vulnerability. The US even considered blocking export licenses for the LEAP 1C engine, a move that could have grounded the project. Every shipment of parts was suddenly at risk, creating immense uncertainty for COMAC. The sanctions aimed to create bottlenecks and prove China couldn't build a modern jetliner without American technology. The C919 became a front line in the escalating tech war between superpowers. Washington hoped to delay and derail the project, betting China wasn't ready to compete. But instead of grounding the Dragon, the pressure would ignite a new determination. The C919 was no longer just a commercial project, it was a symbol of national resolve. The crisis would become a catalyst for innovation. Faced with sanctions, China doubled down on its ambitions. The C919 project became a symbol of technological sovereignty and national survival. Beijing's message was clear: China must achieve self-sufficiency. Engineers across the country were mobilized to replace every foreign component with a domestic alternative. The task was monumental, replicating decades of Western technology in record time. The spirit of self-reliance became a rallying cry, uniting research institutes, universities, and state-owned enterprises. The government poured resources into the effort, fast-tracking funding and cutting red tape. The focus on domestic innovation accelerated, with the CJ1000A engine and key avionics now top priorities. The US blockade forced China to build its own technological bridge to the future. The crisis had become a catalyst, pushing China closer to true aerospace independence. The road to self-sufficiency was filled with setbacks, failed prototypes, missed deadlines, and technical hurdles. But each failure became a lesson, fueling relentless iteration and innovation. Teams from AECC and top universities tackled challenges in materials, software, and design, forging a powerful innovation ecosystem. Collaboration between industry, academia, and the state accelerated breakthroughs. In 2022, the CJ1000A engine completed its first test run, a milestone proving China was on the right track. Domestic suppliers began delivering alternatives for critical systems, reducing vulnerability to sanctions. New factories and standards were established, and a rigorous domestic certification regime put in place. The adversity imposed by sanctions forced China to build the very capabilities it had been denied. The result: a stronger, more resilient, and independent aviation industry. The C919's success is inseparable from the central role of the Chinese state. This was a top-down national strategy, executed with vast resources and unwavering political commitment. The government provided vision, funding, and strategic coordination, investing billions in COMAC, AECC, and the entire supply chain. State-owned airlines became guaranteed launch customers, ensuring production viability. Policies like Made in China 2025 prioritized aerospace, directing talent and resources to the sector. The state orchestrated collaboration across enterprises, universities, and labs, avoiding duplication and accelerating progress. Unlike the West, China's direct intervention was on another level, willing the project into existence. The government was the wind beneath the Dragon's wings. The C919's entry into commercial service marks a seismic shift in global aviation. For the first time in decades, Boeing and Airbus face a credible new rival in the world's fastest-growing market. The presence of the C919 forces a new battle for market share and price competition. Ironically, US efforts to contain China's ambitions backfired. Sanctions galvanized China, accelerating its drive for technological independence. The push for self-sufficiency led to breakthroughs like the CJ1000A engine, making China a more formidable competitor. The lesson: blockades often spur innovation, not containment. The C919 is more than an aircraft, it's a symbol of resilience and the law of unintended consequences. As the C919 fills the skies, it signals a new era in global manufacturing and technology. The Dragon was challenged, but instead of being grounded, it learned to build its own wings. The world of aviation will never be the same.